Okay, so question number 7. Draw the Lewis structure of BH3, which is borane. Note that boron does not have an octet. And this is because boron is one of the exceptions to the octet rule, in which it can be satisfied with only 6 bonding electrons. Part A, which is more electronegative, boron or hydrogen, and B, which atom of borane is most Lewis acidic, boron or hydrogen. Explain your answer. So first, let's just find the Lewis structure of borane. And we do this by finding out the total number of valence electrons in the molecule. So boron has 3 valence electrons, and a hydrogen atom has 1. And since we have 3 of them, we multiply this by 3, giving us a total of 6 valence electrons. So now I'll draw boron as our central atom, and then just draw all of my hydrogens around it. And if I count out how many electrons I have so far, each bond containing 2 bonding electrons, I already have my 6. And the question also hinted that boron doesn't have a full octet, so this is why it is satisfied with only having the 3 bonds. So part A asks which is more electronegative, boron or hydrogen. So let's look up the electronegativity values. So this periodic table just has all the values, and you can also see the trend where it increases from left to right and decreases when going up when going down the periodic table. So boron has an electronegativity value of 2.0, and hydrogen is only slightly more electronegative, having a value of 2.1. So we can say hydrogen is more electronegative than boron. Part B, which atom of borane is most Lewis acidic? So first, let's define what a Lewis acid is. A Lewis acid is an electron pair acceptor. So already, since boron doesn't have a full octet and it has an empty orbital, boron is likely to accept another pair of electrons, making it more Lewis acidic. So I'm just going to write that. Boron is more Lewis acidic since it has an empty orbital to accept electrons. Okay, so let's see what the junior tutor said. Step 1, list the elements and determine the total valence electrons. The charge is present, add the value to the total valence electrons when it is negative, subtract if it's positive. So they also got 6 valence electrons. Next is to draw the skeletal structure. Note that one bond consumes 2 valence electrons. Distribute the remaining valence electrons. Okay, so they only have the 6, so that's why none of the atoms have any lone pairs. Looking at the electronegativities of hydrogen and boron shows that hydrogen is more electronegative than boron. and boron is more Lewis acidic than hydrogen. Lewis acids are substances capable of accepting an electron pair. Once borane forms, the s orbital of the hydrogen atoms will be fully filled, obtaining a noble gas electron count, making it unable to accept any more electrons. On the other hand, boron will only have a non-completely filled orbital, hence not attaining a noble gas electron count. This means that boron will still be able to accept electrons, thus making it more Lewis acidic than hydrogen. Yep, so this solution is correct.